Hello everyone, welcome back to my channel. Today let's go over Weekly Contest 510, question 2. This is a medium level question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this problem without any help. So let's review it and let me show you how I did it. So basically you have an integer array nums and an integer k. What you want to do is scan the array from left to right, as it says there, and process each of the elements. You want to find the minimum total cost to process all the elements modulo mod. So let's go ahead and call this mod is 10 to the power of 9 plus 7. So basically, we're going to scan from left to right, iterating element by element. And basically, we start with our resources, which is going to be k, which is the integer they give you as an input parameter. And cool. So at any point, for example, k after we process this element is 3, after we process this element is 1. So when we get here, we don't even have enough to process 3 anymore. So basically, we can increase by k. So what we want to do is basically if we have 1 and we want to make 3, and we're given 4, how many times do we have to increase 1 by 4 to become bigger than or equal to 3, right? That's the core question we're trying to figure out. And we want to do that the minimum number of times because we're trying to minimize the cost here. So basically, we can just ask at any turn if resources is less than n, then we want to find the number of times it takes, right? Basically, how many times it takes if you take the difference, which is n minus resources. So 4 minus 1 is 3. Divided by 3, that's only 1. We only need 1 that's going to become 5. 5 is already bigger than or equal to 3, right? We can't do 0 because 1 is still less than 3, right? So that's kind of the whole idea here, except there's also a weird constraint where you need to basically increment the cost by 1 each time. First of all, let's just figure out how many costs it will take, how many turns where we're not satisfying n resources being strictly less than n, right? And then figure out how many times we need to increase it. And let's also plus 1 because, for example, you might hit an edge case where it's like 2 and you have 4 and you have 1. So we're just trying to play it safe here by doing a plus 1. And again, if let's just say if resources plus the original times minus 1 is still bigger than or equal to n, then we can just go ahead and subtract 1 because it's still satisfying it, right? So we want the least that we can get, the least number of times we add original times something to become resources, right? To become at least, when you add it to resources, at least n or bigger. Cool. So then we can do this, and what we're going to do is we're going to keep track of how many times we need to do this. So we're going to add 1 to answer, and let's go ahead and just print the answer and just return a dummy value for now. So let's just do this. Let's get rid of the test cases. Let's reset them to what we originally had. Original is also k. Okay, so 0 here, not looking correct. So basically, this is how many times we have to increase it, I believe. So it looks like we want 3 here because this is one time we increment it, and then this time when we add to 1, 4, this becomes 5. 5 minus 3, and then we have to do it again. So that's 2 total increments. So it's going to be 1 plus 2 is 3. If you have 5 increments, is 1 plus 2 plus 3 plus 4 is equal to 15. So that's for this case. And so let's just get the number of total increments we need. So this is actually plus 5. So 5 in total. 1, 2, 3, 4, 5. This is 1, 2. Meaning 1, 2, 3. So 3 in total and 15 in total. So for now, if resources is less than n, because we also have to subtract n at each time, right? Because we have to use it. So the answer in this case is just plus equal to 1 because we want to count how many of those we have, right? In this case, we have 2 increments. So in this case, we want to find the difference, which is n minus resources. And the times would be difference divided by original plus 1, right? How many times we have to increment it. Let's see if that's a little bit better. So it's still not correct, it seems. So difference divided by original plus 1. We want this to show 5. So let's do this the brute force way. While resources is less than n, then basically we have to add original, add this to count, and then increment count, which starts at 1 to follow this sequence. And then we just have to return answer at the end. So this will work, but it's really, really slow. You can see 15 and 0. So you're going to pass most of the test cases, but let me show you again how I optimized it. So you're going to pass what, like 935 out of 964. So again, we're just trying to count how many times we have to do this loop. So basically, again, times would just be the difference, which is n minus resources divided by original and plus 1. So again, if resources plus this many times original is bigger than or equal to n, and we want to do times minus 1, then it's possible, right? It's the edge case that I mentioned. And let's print just the dummy value to see why we are not doing it. Because this should be 5 times, right? Let's print resources and n. 1 and 3. So, oh, we have to actually add times original, right? 1, 2. It's still 1, 2. That's strange. If it's strictly less than n, n minus resources divided by original. Let's do this. It's not correct. I don't know why. So this will obviously bring down the time complexity because otherwise it's really, really high. That the one that I came up with before is an n squared solution. So again, we're trying to look for the difference divided by original, which is k. And then we always have to use that resource, right? So this should print 5 times. I'm not sure why it's not, but we'll keep debugging it. So if we add this is still bigger than our n, then we can say that's 1 less. This is the difference that we need, which is supposed to be correct. So let's see here. After processing nums of 0, we have, so 4 minus 1 is 3. Yep. Let's print resources and n. Yep, so we have 3 here. And then nums of 2 is 7. So how many times we have to increase 2 by 4 to get 7? That needs to happen. Let's print times here. Needs to happen more than once. So 1 and 3 times. So let's actually add times to answer to see if it gives us the correct number of times that we need. Nope, it's still 2. That's very odd. This is 5, that's correct. This is 1. Oh, we're supposed to add 1 because there might be an edge case where it's not exactly like that. So the difference is n minus resources. Let's do difference divided by original plus 1. That's 6, 3, 1. Start this at 0, 0, 5. That's 2. Okay, perfect. Because 2 is 1 plus 2 is 3. That's why we have 3. Perfect. So again, that's exactly how many times we need. And so now we basically know, for example, if answer is 5, then we do 1 plus 2 plus 3 plus 4 plus 5 is 15. So basically, this is almost like a Fibonacci, right? So if you observe this closely, there's a nice equation you can use. Just return, so the value is answer, which is 5, plus answer plus 1 divided by 2. So 5 plus 6 answer plus 1 divided by 2. Let's try that to see if it works. 3, it's supposed to be 8. That's not correct. So it's times, I believe. So answer times, perfect. So 5 times 6 is 30 divided by 2 is 15. Perfect. So that kind of gives us exactly what this sequence is, as you can see, because we're kind of accumulating all the differences at once and adding them together. And then that's how many times we have to increment each time we add, right? Cool. So let's submit this. Okay, last but not least, let's do this one modulo mod, as it says in the instructions. And let's try it again. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve this question completely on my own. So that's it for question 2 of Weekly Contest 510. This is a medium level 4-point question.